Hello to my channel Psychometric Solutions. In this video, I am going to demonstrate how to do multiple regression analysis in the SPSS. Before this, let me explain a little bit about the regression analysis, especially it would be useful for the beginners. A multiple regression analysis is actually a statistical technique that can be used to analyze the relationship between a single dependent variable, which is also called criterion variable, and several independent variables, which are called predictor variables. The objective of multiple regression analysis is to use the independent variables whose values are normally known to predict the dependent variable. A typical regression model is like this. We have y, which is dependent variable. A is the alpha intercept, which is also known as a constant. It is the point where the regression line intercepts the y axis. B is actually the beta coefficient, and it is a regression coefficient, and it shows the amount of the change in the dependent variable corresponding to the change in the dependent variable, whereas x is the independent variable, also known as predictive variable, and E is also called the error term or epsilon, which is actually the difference between the actual and the predicted values in a regression model. So this is a simple regression model. It could have more than one independent variable. Like here we have two independent variable. We can add more like x3, x4, x5 depending on what kind of analysis we are doing. So this was about the regression model. Now let's come to the example which we will run on the SPSS. But before this, one should keep in mind that the regression analysis requires the fulfillment of the prerequisites of the multivariate data analysis, including checking the data normality and linearity, the homoscedasticity, multicollinearity. If you have any issues in any of these prerequisites, you will not be able to run the regression analysis in such a way that the regression analysis will not predict in a good way the dependent variable. So let's suppose we want to know the relationship between job stress and job performance, and our research question is that what is the relationship between job stress and job performance, and from this we make a hypothesis that job stressors will be the predictors of the job performance in such a way that job stressors will be negatively related to job performance. Now this is just an example, a very simple example, that we have two variables. One is the job stress, other is the job performance. The job stress has further sub-dimensions which are known as job stressors. So we want to check whether these two variables are related with each other or not. So to check this, we go to the SPSS. In the SPSS, you can see here in the columns, we have these four variables: the job performance, which is the dependent variable, while these are the job stressors, the independent variables, three dimensions of the independent variables, that is interpersonal demand, emotional demands, and workload. So to run the multiple regression analysis, we go to the analyze, click on the analyze, go to the regression, and then go to the linear and click on it. Here you can see we have a separate boxes for dependent and independent variable. So as we know that job performance is our dependent variable, so we enter the dependent variable into the dependent box. And these three are the independent variable, also known as the job stressors. So I select them all and enter into the independent box. Then I click on the statistics. I click on the R square change. I click on the collinearity diagnosis. It would help me to know whether my data is free from any issues of collinearity. Then I click on the continue. Then I click on the plots, and we have here histogram and normal probability plot. This will help us to know whether the data is having or not having any issues in the data normality. So I enter the ZPRED into X, while the ZRESID into the Y. I click on the histogram, normal probability, and I click on the continue, and then I click on the OK. Here you can see we have these series of boxes which would help us to know whether there is a relationship between the dependent and independent variables, and these series of boxes are the part of the multiple regression analysis. It means that when you are interpreting the results of the multiple regression analysis, you need to interpret each of these boxes. So first we have the model summary. We can see here the R square is 0.48, while R square change is 0.48. This is significant at 0.00 level. You can see here the F value is 94.88. Now this means that the independent variable has been changed, or we can say that the independent variables have made a change in the dependent variable, that is 48% change. The R change square shows that the independent variables have brought 48% of change in the dependent variable. Here you can see the ANOVA, the F value is significant at 0.00 level. It means that there is a relationship between the dependent and independent variable, and this relationship is significant. Look at the beta coefficients. We have the standardized beta coefficients which are all negative, and they are significant at 0.00 level. The collinearity statistics show that the tolerance and VIF values are all within the acceptable range. It means there is no correlativity issue. And now let's come to the histogram and normal PP plot. So it has a good bell shape. It means the data is normal. The regression line is all of these regression weights are on the regression line. So it means that we don't have any issue in the data normality. The scattered plot also show that we don't have any outliers, or we don't have any multicollinearity issues, and this is a normal scattered plot, and you can see here this is showing a negative relationship. The direction of the scattered plot is in the negative side. So as we can see here, all of the three stressors are negatively related with the dependent variable. So our hypothesis that the job stressors will be negatively related to the job performance has been accepted. In this way, we can interpret and we can use the regression analysis. In my next video, I will tell you about the hierarchical multiple regression, in which we enter the data stepwise into the regression model and then we interpret these results. So that's all for today.